So think about every single dot on a hamburger bun. You've probably eaten, tens of thousands of sesame seeds in your lifetime, right?
Yeah.
Pressed into snacks or, baked onto bagels.
Oh, absolutely. Yeah, thousands easily.
Right, but you've probably never stopped to think about the high-stakes microscopic waiting game that actually
Right.
gets them onto your plate. Every single one of those little seeds is essentially the survivor of a violent biological explosion.
It is, yeah. We just interact with this millimeter-wide final product and treat it like background noise in our culinary lives, honestly.
Yeah, exactly.
But the actual biological journey and really the sheer mechanical tension involved in harvesting that seed, it remains completely invisible to the people who are just eating it.
And bringing that invisible journey into focus is the mission of today's deep dive. We're exploring this really fascinating, hyper-focused piece of personal gardening documentation. It's a dispatch that is simply titled Notes on Gardening, Part 891.
The dedication embedded in that number alone is it's staggering to me.
Right, Part 891.
Yeah, you immediately realize you're in the hands of an observer who has completely mastered the art of slowing down and paying attention to these really tiny micro details.
Yeah, so our author, a gardener named Ang, is documenting the life cycle of the sesame plant, which is scientifically known as Sesamum indicum. But we're looking at much more than just botany today. We're unpacking this really profound tension between strict agricultural control, like the human need to extract a yield, and the philosophy of just stepping back to let complex natural systems run their course.
Right, and the scene opens during the rainy season, which, for this plant, triggers a massive biological transition. The aesthetic phase is basically ending, so the delicate flowers fade, and the plant aggressively shifts all of its energy into its reproductive phase.
Which means the seed pods are forming.
Exactly. The capsules or seed pods begin to form.
And the visual description of these pods in the notes is just striking. Like, they're fuzzy, they're oblong, and this is the weird part. They don't just hang off the branch like an apple or something.
No, not at all.
They grow pointing straight upwards, specifically emerging from the leaf axils. Okay, let's unpack this for a second. I always picture that junction as a kind of architectural buttress, almost.
That is actually an incredibly accurate way to view it. For those less familiar with, botanical anatomy, the leaf axil is that precise angle where the leaf stem anchors into the main vertical stalk of the plant.
It's like the little armpit of the plant.
Yeah, the armpit. And it is the strongest, most protected structural junction available. The plant is essentially using its own heavy-duty architecture to support the increasing weight of these future seed pods.
Because they're going to get heavy.
Oh, very heavy.
Yeah.
Growing upwards from that nook ensures the capsule is cradled against gravity.
It's just brilliant structural engineering. It reminds me of, like, tiny green rockets waiting on a launch pad.
Yeah.
Just pointing straight up.
I love that visual. Yes, exactly, like little rockets.
But, once those fuzzy upward-pointing pods form, the plant enters what Ang describes as a waiting game. And I kind of have to push back a little on the romanticism of this phase, honestly.
How so?
Well, gardening so often sounds like these agonizingly slow periods of just staring at a green pod, right?
Mm-hmm.
Playing waiting game for weeks until it turns brown. In a world where we expect instant results, this waiting period feels almost, frustrating. Why is gardening just waiting around?
I think the frustration comes from confusing stillness with inactivity, While the outside of the pod just looks like a static green capsule, the inside is its factory operating at maximum capacity.
Oh, wow.
Yeah, the plant is drawing up immense amounts of water from the rainy season soil, synthesizing these complex starches and oils, and aggressively packing all of that life force into tiny microscopic specks inside the pod walls.
So it's like invisible manufacturing.
Exactly. And reading through the source notes, you really get struck by the pure curiosity of the observer during this period. Ang looks at this single fuzzy oblong pod and just wonders, how many tiny seeds could possibly be hidden inside this one little space?
Right.
And that curiosity is the defining difference between observing a natural system and simply demanding a product from it. The focus is entirely on the mystery of the biological process. Ang is marveling at the sheer scale of reproduction happening inside a space the size of your thumb.
But the manufacturing phase inevitably ends, right? The green pods eventually turn brown, which signals that the quiet, aesthetic portion of the plant's life is totally over.
That's right.
And this brings us to the dramatic climax of the sesame pod's life. And functionally, this is a massive logistical nightmare for anyone who is trying to grow this crop for a living.
Oh, it's a huge headache for farmers. The transition from green to brown is where the tension quite literally builds.
Mhm.
We really have to look at the specific cellular mechanism of what happens when that pod matures. It's a biological process called dehiscence.
Dehiscence. Okay. Because they don't just, like, gently unfurl and offer up the seeds like a blooming flower, do they?
Far from it. As the pod matures, the moisture begins to evaporate from the cellular walls of the capsule. But here's the trick. It does not dry evenly.
Oh, interesting.
Yeah, the outer layers of the pod shrink faster than the inner layers. So this differential drying creates immense mechanical tension across the structure of the pod.
Oh, wow.
It acts almost like a tightly wound rubber band or maybe a loaded spring.
Here's where it gets really interesting to me. So the plant is essentially weaponizing its own dehydration.
Precisely. It really is. The seam of the pod acts as a biological fault line. The mechanical tension just continues to build as the water leaves the cells until suddenly the pulling force exceeds the structural integrity of that seam.
And then what?
The pod shatters. It violently snaps open, ejecting the seeds instantly in all directions.
It behaves exactly like a loaded mousetrap. I mean, it's like a high-stakes game of operation. 1 second, it's a closed pod, and then a fraction of a millimeter of drying later, it snaps, and your entire harvest is just scattered into the dirt.
Yeah, it's gone.
And from a commercial standpoint, you can't exactly break out a tiny vacuum and suck up millimeter-wide sesame seeds from the dirt once they fall. They're just gone.
Right. From the farmer's perspective, it's a disaster. But from an evolutionary perspective, the plant is executing its survival strategy flawlessly. The Sesamum indicum is not optimizing for a baker's yield, you know?
Right, it doesn't care about our hamburger buns.
Exactly. Its only imperative is to violently fling those seeds as far away from the parent stalk as possible, ensuring they have fresh soil and sunlight to dominate the area during the next rainy season.
And humans have spent centuries trying to outsmart that exact evolutionary strategy. Because this shattering is so sudden and totally uncontrollable, farmers have actually engineered a highly specific, kind of counterintuitive intervention to stop the pods from exploding and ruining the crop.
They have. It's really clever.
They physically cut down the entire stalk and tie them together in upright bundles to dry.
The intervention is an attempt to completely hijack the plant's own biological timeline. And the timing of the cut is the absolute most critical variable in the entire operation.
And this is exactly where I get hung up on the agricultural math of it all. Because the source notes detail that farmers cut the stalks as soon as only the bottom pods turn brown.
That's right. Just the bottom ones.
But the vast majority of the plant, like everything from the middle to the top, is still covered in unripe, fuzzy green pods. So wait, if they cut the stalk when only the bottom pods are ready, aren't they sacrificing the whole top half of the plant's yield? How does the math on that work out for a commercial farmer? Doesn't that seem premature?
It seems like a massive miscalculation, yeah, until you factor in the growth habit of the plant. Sesame has what's called indeterminate growth,
Meaning what exactly?
meaning it matures from the bottom up. So the pods anchored at the lowest leaf axils, those little armpits we talked about, are the oldest, the fattest, and the very first to experience that extreme mechanical tension.
Okay, I see.
If a farmer waits for the top of the stalk to ripen,
The bottom pods have already shattered like a mousetrap.
exactly, you lose the biggest, most valuable seeds straight to the dirt.
Which forces the farmer to make a calculated compromise. So you cut the stalk early to save the premium bottom seeds. But the brilliance of the human intervention is what they do next, right? They don't just lay the cut stalks on the ground.
No, they bundle them together and stand them completely upright.
They're keeping the architectural orientation perfectly intact. But why is standing them upright so essential? I mean, a cut stalk is a cut stalk, right?
You'd think so, but the severed stalk is not entirely dead yet. This is where it gets amazing. By standing the plant upright, the farmer utilizes the plant's remaining vascular system. Yeah, the residual moisture and energy stored in the stalk are forced upward via capillary action. The dying plant basically goes into overdrive, pumping its absolute last available resources into those unripened green pods at the top.
Artificially pushing them to maturity.
Yes, exactly.
It forces the plant to finish the manufacturing process
Yeah,
even after it's been disconnected from the earth. That is wild.
it's ingenious. And as those top pods eventually turn brown, dry out, and hit that critical threshold of mechanical tension we talked about, they inevitably shatter. but because the stalks are tightly bundled upright.
Gravity finally works for the farmer rather than against them.
Exactly. The seeds shatter, but instead of flying everywhere, they just fall downward into the dense bundle of stalks or onto a tarp that the farmers place directly
So
underneath.
the farmer is literally using the violent biological explosion against the plant itself.
Yeah.
They're trapping the seeds in a highly engineered, deeply controlled environment.
It really is the ultimate expression of agricultural control. They're maximizing yield by outsmarting a million years of evolution. The farmer tightly controls the timeline, harnesses the capillary action, and manipulates gravity to prevent a single seed from escaping into the wild.
It is a ruthless but just brilliant system.
Yeah.
You really have to respect the sheer ingenuity of outmaneuvering nature like that. But, and this is where the narrative pivots, looking at our source material, Ang takes a long look at this ticking botanical mousetrap, completely understands the commercial method of cutting and bundling, and makes a deliberate decision to do the exact opposite.
Yes. The narrative shifts here from just a biological observation into a much deeper philosophical stance on how we interact with the natural world. Ang actively refuses to step in.
Yeah, the notes explicitly detail the choice not to cut the stalks early. No upright bundles, no tarps. Ang looks at the mature brown pods and decides just to leave them alone, letting the mechanical tension build until they shatter totally naturally.
Ang is surrendering control to the plant's original evolutionary design.
Now, I have to play devil's advocate here for a second because this directly challenges the entire premise of cultivation. I mean, if you spend all this time growing a plant, navigating the rainy season, monitoring the slow biological manufacturing of the seeds, why let them just explode into the dirt? Aren't you essentially losing your own harvest?
Well, if we connect this to the bigger picture, the conflict really lies in how we define a harvest.
Okay.
You're evaluating the garden through the lens of extraction. For a commercial farmer, survival absolutely depends on a managed open system. Inputs go in, and a maximum yield must be extracted out. To them, every seed that hits the ground is lost profit.
Right, it's a failure of the system, a metric of lost efficiency.
Exactly. But Ang operates on a completely different metric. Ang values the continuous cycle over the immediate yield. By actively allowing the plant to shatter, Ang is trading a short-term extracted harvest for long-term sustainability.
I see.
The violent explosion of the pod isn't a loss, it's an investment.
So what does this all mean? The notes mention the goal is to let nature take its course so the plants can reseed themselves for the next cycle. Ang is essentially like firing themselves from the labor of planting next year.
Yes. The garden transitions from a tightly managed factory into a self-perpetuating closed-loop system. By relinquishing the need to trap and control every single output, Ang trusts the biological mechanisms that kept the plant alive long before human intervention ever existed.
The contrast there is just striking. The farmer operates from a place of necessary scarcity, terrified of losing a fraction of a millimeter of yield, tying everything into these rigid, upright bundles. Whereas Ang operates from a place of abundance, trusting that the sheer volume of seeds inside that tiny capsule is more than enough to sustain the system without human micromanagement.
And this raises an important question, right? It challenges how we think about the systems we build, both in agriculture and in our own personal lives.
Oh, totally. We often default to the farmer's mindset. We tightly control timelines, we bundle our projects rigidly, and we micromanage outcomes because we are terrified of losing efficiency.
We try to catch every single falling seed. We're terrified that natural scattering is synonymous with failure.
Yes, exactly.
And look, in certain environments, that strict control is absolutely necessary for survival. The farmer needs to make a living. But the counter approach is really worth considering. Ask yourself, what would happen if we occasionally adopted Ang's philosophy? Identifying the systems, the creative projects, or the environments where we might actually benefit from stepping back and letting the complex natural mechanics run their course.
Redefining success from what we can violently extract and tightly bundle to what we can sustainably set in motion, like a harvest of continuity.
It shifts the entire perspective. The harvest is no longer just a jar of extracted sesame seeds sitting on a shelf. The harvest is the garden's ability to perpetuate itself entirely on its own.
Taking a step back, this has been an incredible lens through which to view something as mundane as a hamburger bun. I mean, we started by exploring the architectural brilliance of the Sesamum indicum during the rainy season, utilizing the leaf axils to buttress those fuzzy, upward-pointing pods.
Right. And then we dissected the invisible biological manufacturing happening inside the capsule. And of course, the sheer mechanical tension of dehiscence, the drying cell walls turning the pod into a loaded spring.
And we looked at the mathematical pragmatism of the human intervention, too. Outsmarting the plant's bottom-up maturation by cutting stalks early, harnessing the dying vascular system, and utilizing gravity to trap the violently ejected seeds.
Ending with a pretty profound philosophical pivot. That conscious choice to reject that strict framework of extraction, opting instead to let the biological mousetrap snap naturally, transforming a managed yield into a self-sustaining cycle.
Every single sesame seed you encounter is either a captive of that tightly controlled agricultural bundling or the survivor of a violent natural scattering.
It's a phenomenal amount of biological tension, human engineering, and philosophical weight, all contained within a fraction of a millimeter.
It absolutely is. And we want to leave you with one final thought to mull over today. Think back to Aang's pure curiosity during that long waiting game, staring at the fuzzy green pod and wondering just how many microscopic seeds were hidden inside.
While we never received an exact count in the notes, the biological imperative of the plant ensures it's a massive multitude.
A multitude designed to explode outward. If a single shattered pod holds enough potential energy and raw material to successfully reseed the ground for an entire subsequent cycle, imagine the exponential growth that comes from simply letting go. We spend so much energy tightly binding our ideas, our teams, and our goals, terrified of losing a fraction of our intended yield. But what seeds of ideas or projects in your own life might actually multiply if you stop trying to harvest them perfectly? What could happen if you step back, allowed the tension to release naturally, and trusted those seeds to scatter and take root entirely on their own?